Your computer does not use just one address to send data. It needs two. One address tells the internet where the packet is going. The other tells your local network which physical device should receive it next. Imagine your laptop sends a message to a server. There are billions of devices on the internet, so how does your packet find exactly the right one? The simplest idea is shouting. Send the packet to everyone and hope the right machine answers. But that only works in tiny networks. If the whole internet worked like that, it would collapse instantly. So the network uses a smarter system. To understand it, we need four pieces: IP, MAC, ARP, and NAT. First, the IP address. Think of it as the destination written on the packet. Every packet has a source IP and a destination IP. The source says who sent it, the destination says where it should end up. Routers across the internet mainly care about the destination IP. They look at it and decide which direction to send the packet next. But here is the twist. Inside your home network, the switch does not deliver packets by IP. It delivers them using a different address, the MAC address. A MAC address belongs to the network hardware. Your Wi-Fi card or Ethernet card has one. IP addresses can change when you move networks, but the MAC address is tied to the physical device. So now we have two jobs. IP answers, where is the final destination? MAC answers, which physical device gets the packet next? But now we have a problem. Your laptop may know the destination IP, but how does it know the MAC address for that IP? That is the job of ARP. ARP is basically your computer asking the local network who has this IP address. The device that owns that IP replies, that is me. Here is my MAC address. But ARP has a limit. It only works inside your local network. Your laptop cannot shout across the entire internet asking for Google's MAC address. So when the destination IP is outside your network, your laptop does something clever. It does not ask for the server's MAC address. It asks for the router's MAC address. This is the part that many beginners miss. When your laptop sends a packet to a website, the destination IP is the website, but the destination MAC is your router. Now we hit the next problem. Your laptop probably has an IP like 192.168.1.5, but millions of other laptops also use that same private IP. So the public internet cannot send replies directly to it. That is why your router uses NAT. NAT lets your private devices share one public IP address. Inside your home, your laptop is 192.168.1.5. Outside your home, the internet only sees your router's public IP. When your packet leaves home, the router rewrites the source IP. It changes it from your private IP to the router's public IP. Then it remembers the translation in a small table. When the server replies, it replies to the public IP. The router checks its NAT table, sees which private device started the conversation, and sends the packet back to your laptop. Now the whole journey makes sense. Your laptop uses ARP to find the router's MAC. It sends the packet to the router. The router uses NAT to replace your private IP with a public IP. The internet routes the packet by destination IP. The server replies, the router reverses the NAT, and your local network delivers it back by MAC. So remember this. IP is for the final destination. MAC is for the next physical hop. ARP finds the MAC address for a local IP. And NAT lets private devices share one public internet address. But there is one more question. Between your router and the server, there may be dozens of routers. So who decides the path? That is the next video. How routers choose the path. Subscribe for one networking concept explained clearly every week.